Okay, so chapter 11, we are going to talk about the properties of logarithm. So first of all, let's review to see what we have. So y was equal to log of x b. So this was x equal y power b, right? So let's see if you remember. 10 power 4, 10 is equal to,
We didn't find the power.
huh?
We didn't find the power.
So what is 10 power 4? You should know what is 10 power 4.
4,000.
10 power 4 is
400.
1, 2, 3, 4. Right? 10,000. Correct? So now tell me. What is the answer?
1,004.
What is the
10.
question mark?
5.
Huh?
10.
10? Yes, 4. This is the amount of extra credit. You should notice that easily. Okay, so this one is y equal 4.
So it's y equal to 4
Because 10 power 4 is 10 power 4, right?
oh,
B power y is, oh, actually this one is b power y. Am I right? No, it's correct. Correct? This one, power, this one gives us this one. Am I right? So, and one more thing. So, y is equal to log 416. What is y?
4.
2.
Oh.
God. 4 power 2 is 16, isn't that?
Y equals to, oh, the power of the number goes.
Another one.
Okay.
Log. One over 8, 2.
1 over 4.
Negative
Negative.
negative 3.
Negative. Oh,
Negative
yeah, negative
3. Because 2 power negative 3 is
8.
1 over 8. Right? So if our logarithm doesn't have anything here, what this means, do you remember?
10.
10, exactly. Correct. This is 10. So if I didn't write down anything here and I gave you 10 power 4, the answer would be
10.
4.
4.
The answer would be 4, right? Because this would be 10 and 10 power 4 is 10 power 4. Okay, so now the properties of logarithm. If we have two logarithms with the same base, log 2, 5 plus log 2, 7. Let's make it 11. Okay.
Oh, I know what to do. You do.
Oh, actually.
You do log power.
You will say log. These 2 will multiply. 5 multiplies to 11 base 2. So you will have log 55 base 2. So from here we will have these properties. If base are the same, you will add these 2 numbers. You will multiply these 2 numbers. You will have m multiplied to n. Base is b. Correct? Another property says, so now if we have minus here, you will divide the first one by the second one. So you will have 5 over 11. So that's why we will have log m b minus log n b equal to log m divided by n b. Okay, so these are the 2 properties. And then the other one says, if we have like this, log 10, and you know obviously base is 10, right? And this one has a power. So what we do, we bring this power here before log, and then multiply this number to log of 10 with the same base. So the base is 10, right? So do you remember what was the log of b? 1, exactly 1. Because b power 1 is b. Correct? And then if you remember, log of log 1, any base is always equal to 0. Because b power 0 is 1, right? So this one, let me write it down as a row. So actually it's, I should follow that. Log of m power t base b, p multiply the log of m base b. Okay, so now an example. So we have log 8 base 2. We want to see what is the answer. Three, yes? But now look at this. We can write down log of 2 power 3 because 8 is 2 power 3, right? And then base is 2, correct? And then we use this rule. Bring this power here before log, and then you will have 3 log 2 base 2, which is 1, right? So 3 multiply 1 is 3.
So the answer would be 3.
Mm-hmm. So you already know what is the answer, but I'm saying using this rule also gives you the correct answer. For example, log base is 3 and we have $81 81 is
5.
4 power 4, right? 3 power 4, correct? Because 81 is 9 multiply 9. Each of these 9 is 3 power 2, right? You have 3 power 2 multiply 3 power 2, which is 3 power 4, correct? So you will have log 3 power 4, 3, which is equal to 4 multiplies 2 log of 3 base 3, which is 4 multiplies to 1, right? 4 multiplies to 1 is 4.
So you'd multiply what equals, you'd multiply the power by 1.
Why I do that? Because we know log of 3 base 3 is equal to 1. Because it is log of b base b, right? Which is equal to 1. So you multiply 4 to 1. The whole thing is 1. So that's why. If I had 4 log 2, 3, I couldn't do that. I couldn't continue, right? Because this one doesn't, it's not equal to 1, that's why. Okay. Look at this one. It says log of m plus n is not equal to log of m plus log of n. If we have addition between two logarithms, we should write it down in this way. We cannot add m and n, right? If we have a negative sign between two logarithms with the same base, we cannot subtract this from this one. We should use the division. So it's just saying that. Don't get confused. Don't have mistake like that. Okay, so let's solve this. Okay. So the question says, let's say we have log 5 power x. So that is the power of 5. It goes here. We have log 5, and obviously you know the base is 10, right?
Because they didn't give us.
Exactly, they didn't give us. The next one is log 32 power x plus 2. So first of all, bring the power here. Then we have log 32, right? And 32 is 2 power
16.
No, 2 power 5.
5.
Am I right? 2 multiply 2 multiply 2 multiply 2 multiply 2. 8 multiply 16, and 8 multiply 2 is 16. 16 multiply 2 is 32. So it's 2 power 5, right? So I will write down x plus 2 multiplies to the log of 2 power 5, right? And then again I have another power here. So I can write down 5 multiply x plus 2 log of 2 base 10, right? Do you have any question here? Is this clear? Oh, good. Now it says we have log of radical x. From previous lectures, we should know that the radical x can be written as x power 1 over 2. Because the power of x is 1, the index is 2, we have 1 over 2. Do you remember? A power m, index n, is equal to a power m divided by n. That's why.
For that last problem, that would be our answer right there.
Which one?
5.
This one? Yeah.
Yeah.
So here log of x power 1 over 2 is equal to 1 over 2 comes here. Log of x, the index is 10. We have log. Base is 3. The argument is 29 divided by 7. So I'm going to use the second properties. Let's say this one is 1, 2, 3. The second one. As you see, that is m divided by n, right? So I will go from the right side to the left side. So I will write down log of m minus log of n. Base is the same for both of them. Do you have any question? The next one says log of b 36 minus log of b 9. These are complete square, right? 6 multiply 6 or 6 power 2. Correct? And that one is 3 power 2. So let's write them. Log of 6 power 2 b minus log of 3 power 2b. And then these 2 goes in front. We have log 6b minus 2 times log 3b. Am I right? Now factor out the 2 because it is common between 2 of them, right? So bring out 2, we will have log 6b minus log 3b. Do you get this? So now inside the parenthesis, we have 2 logarithms, subtract from each other. We have the same base. We are going to follow the second rule. Okay? So we'll write down. Keep the 2 outside. We will write down a log with the same base, 6 divided by 3. Second rule says m divided by n if you have negative sign between these 2 logs. So now continue that. Log of 6 divided by 2 is 2 base b. Correct? So now this one. We want to write this down as a single logarithm. One over 3 log x b plus 2 log b w minus 3 times log b z. So here for this logarithm, the only thing I have in common is the base. So I cannot bring out those coefficients in front of each of them. Like I cannot bring out 1 over 3. I cannot use that 2. So what I do, I put them back in a power, like in a power form for this x. So 1 over 3 goes here on power for x, and 2 also goes here for a power of w. Z also will have 3 as a power. So we will write them in this form. So the first 2 is addition, right? So m will be multiplied to n. So we have a log with base b multiplying x power x power 1 over 3 to w power 2. Then the rest is here. Correct? So now we have a negative sign between two logs which have a same base. So now we should divide this argument by this second one, right? And we can combine these in just one log. Okay? Oh. So this is the way we combine logarithm. This is the answer. Now we have one logarithm, we want to separate them. We want to make it like 3 logarithms. Okay? Did you write that?
Wait, what's the answer for that last one? Oh, that one.
We have log base b, and we have an argument like this: x power 4, y power 3, divided by z power 2. So now I want to separate the numerator from the denominator. So I will need 2 logs with the same base. Numerator minus the other log, which is the denominator. So x power 4, y power 3 with the same base minus log z power 2 b. So it's like a kind of the first backward of the first one. First example. Example before. Then here I have multiplication. I can separate them to the addition of log power. Log with this argument minus the rest of thing z power 2 b. So now we can bring this power behind the log here. Front of that. 4b plus 3 times log y b minus 2 times log z b. This is y.
So why did you put 4?
Because that is the power of x. We can bring it using which rule? Rule number 3. The next question, now we want to solve the equality. So we have log x base 2 plus log 5 base 2 equal 3. These two have the same base. That's why I'm going to use the properties of logarithm to solve this. So I can write down 1 log with base 2 x multiplies to 5. So instead of x5 we can write down 5x equal to 3, right? So now imagine you have a logarithm with all this information. So you know that this one base power, this number here, will give you 5x, right? So what I said, 2 power 3 will give you 5x. Can you solve this now for x? I mean, this is easy now, right? Because 2 power 3 is 8. 8 is equal to 5x. So x is equal to 8 divided by 5. Correct? No. So the other example says we have log base is 3, argument is x plus 4, minus log base is 3, argument is x minus 4, and then this one is equal to 2. So, with rule number 2, combine the left side of this equality. With rule number 2, combine the left side of this equality. So you will have log with base 3, right? And then the argument would be so we have log base is 3, x plus 4 divided by x plus x minus 4 equal to 2. And then what should I write down now? 2 power 2 is equal to
X plus
4 divided by x minus 4, right? I know that is 9. But let's write down everything and then we will write down 9 here. Equal to x plus 4 divided by x minus 4. Okay, solve this for x. Solve. x is equal to 5. 5 plus 4 is 9. 5 minus 4 is 4. Right? Correct? Huh? So we will say 9 multiplies to x minus 4 is equal to x plus 4. Right? So these two multiplies give us x plus 4. 9x minus 36 gives us x plus 4. This x goes to the other side. We have 9x minus x. 36 goes to the other side. We have 4 plus 36. So 8. X is equal to 4, 0. X is 5. Right? Do you have any question? Evaluate log 7 base 7. Tell me fast. What is log 7 base 7?
1.
1, right? Log b base b is 1. What about log 1 base 5?
0.
Right? 5 power 0 is 1. Correct? Then it says find x if log x3 is equal to log x. Okay, let us find this. Log 3 argument is x equal to log 3 argument is 17. Well, kind of obvious, huh? Isn't that?
Log x divided by 17.
What is x here? 17, right? Otherwise it wouldn't be equal, huh? So it should be exact same. Base are exact same, so these two should be exact same, right? So it says log 12, log actually, this one, I want to solve this one. Log 13 base 12 equal to log of y plus 2 base 12. So we want to solve for y. Base is 12. In here 13, in here y plus 2, base is 12. So if base are the same, those argument has to be the same, huh? Like the previous one. We had x 17, you said x is equal to 17. So these two have to be the same. So 13 equal y plus 2, we solve this. Because the base is the same, these two should be the same, right? So we solve this. Y is equal to 13 minus 2, which is correct? Do you have any question? Is this easy? So next one says we have 2 times log 7, 3 minus 4 times log 7 to log 7x. Put these numbers back to the power, and that would be the first step. So we'll write down log base is 7, base is 7 log. So this will be 2 power 4. This will be 3 power 2. Right? Correct? Okay. So now I want to combine these two. There is a negative sign between them, so I will follow this one. So m divided by m. So let's write down log base 7, 3 power 2 divided by 2 power 4 is equal to log base 7 x. So let's rewrite this. Log 9 divided by 16 equal to log 7x. So what is x? X is 9 over exactly 9 over 16. Okay, now solve this one on your own. This one. Are you done? What is the answer? 2/3. Okay, so anyone else? Let's see. So on this side we have log 3, 2/5, right? Because we have negative sign between these two. On the other side we have log 3, 6x, right? So from here, the base are the same, so these two arguments, they have to be the same, right? So we have 6x equal to 2/5, right? Multiply the both side by 5, we will have, oh actually, we want to find x, right? If we want to find x, we should divide both sides by 6. So we will have 2/5/6, which is this one, right? So it will be 2/30. Okay? You forgot the 0. Right? Two over 30 is 1/50. If you want to simplify that. Okay, combine these to one logarithm. And then this one also separate them to 3 logarithms. So the first one is log base 4 w plus log base 4 x plus log y base 4, right? The second one is log 7 8 multiply x multiplies to w. That's it.
It doesn't matter the order.
No, it doesn't. Now, write in logarithmic form and write in exponential form.
We're doing 1 and 2, right?
Mm-hmm. Okay, so imagine this one is b, this one is y, this one is x. So we have b power y equal x is exponential form, right? And then we could have y equal to log x base is b, right? So if we have such a thing, which is exponential form, we can write down y equal to y is 2. Log of base is 749. Right? Is this correct? So this one will be -2 equal to log base is 4 and argument is 1/60. Okay? Base power 3 is equal to 125, right? 5 power 3 is 125. Here, 2 power -3 is equal to 1/8. So this one I will write down b power 3 is equal to 125. What is b?
5.
5. Right? This one I will say 1/2 power y equal to 32. So instead of 1/2, I can write down 2 power negative 1, right? Yes. Let's write down 2 power negative 1. Power y is 32. Then I will say 2 power negative y is 32. So what is y? If you put 5, you will have 2 power negative 5, right? So what you should put to have a correct answer? Negative 5, right? If you have a negative 5, it will be 2 power negative of negative 5, which is 5. And then you will have 2 power 5, right? So, if y is negative 5, we will have 2 power negative 5, which is 32. And this is correct.
So you're just kind of doing it like backwards.
So the last one, what is your answer here? Y is 10 power something is 0.1. Please. 0.1 is 1/10, right? Maybe that helps you. 10 power y is 0.1. 10 power y is 1/10. So reciprocal of 10. What should we do? What power 10 should have? To have a reciprocal like this.
A negative.
Negative what?
Negative 1.
1, right? Negative 1. So 10 power negative 1 is 1/10. So y is negative 1. Correct? Oh. Do you have any question? Yes. Okay. So your exam is on Monday. In class, be on time. And it will be from the last chapters we talked, 7, 8, 9, 10. 7, 8, 11. Okay? So bring a kind of, a big calculator is actually important. Bring your calculator with you. A card, you can have a formula card, 5x8. You can write down all the formula for yourself. And what else? And actually exam is multiple choice. Be careful, write down all the answers in that paper, like in the exam paper. And also choose the correct answer in the answer key. And you should have a pencil. a pencil for that answer key, okay?
How many questions are there?
20.
20.
Mhm. Yeah. Okay, do you have any question? No? We'll see you on Monday. Study hard.